Hey guys, it's me. Just so you know, this is the third time I've tried to record this. These things are not easy to do. Anyway, I told you I'd give you a video on going through this guided notes on impulse. So here are the notes. Um, you should have a copy of it in front of you. If you don't, pause this video and go get a copy of it. Otherwise, it's not going to sink in. When you just see something, it just doesn't register. When you do something, uh, you remember it better. All right, so I'm going to start with the questions. They're not numbered, but I'll work through them. All right, impulse is the rate at which something changes. What's that something? I'm sure a couple of you know, but I'll give you a minute to figure it out. Well, not a minute, a few seconds. If you don't remember, here's the answer. Momentum. Impulse is the rate at which momentum changes. Now, if we talk about rate, we're talking about an event in a given amount of time. So we know that momentum is changing, and we know that it's going to be changing in a given amount of time because it's a rate. So we're going to have to put time into the formula, and we're going to have to put momentum into the formula. So anybody know? Good. All right, so I'm going to, come on, it's not working. There we go. Draw. Have to push pretty hard. Alrighty. P equals, I'm sorry, impulse, I'm sorry, momentum is P. Delta P over delta T. Good enough. So, change in momentum over change in time. Momentum is, okay, P equals mv. All right. So, mass is kilograms, and velocity is meters per second. So, delta P over delta T gives you some value of kilogram meters per second. All right. Now, momentum itself is the amount of energy available to apply at impact. The faster you're going, the more energy you're going to have, and the larger the force. So, momentum is the amount of energy available to apply at impact in what? The units. Well, we just did that right here. And kilogram meters per second is equal to, sorry, a Newton second. All right. That was a crappy second, wasn't it? That was not much better. It looks like a G. I'll get it right. Hang on. There we go. So, we're talking about impulse. We're talking about impulse being the change in momentum over change in time. So, impulse is how long the what occurs. You could answer this in two ways. You could either say the collision, or you could say the change in momentum. So, I'm just going to write delta P. All right, change in momentum. The longer it takes to transfer the momentum, meaning the longer the collision, the greater or smaller the impulse. What do you think? If it takes a long time to stop, does the force on you, is it large or is it small, as opposed to jamming on the brakes? Well, the longer it takes you to transfer momentum, the smaller the impulse. In other words, the faster you stop, the greater the impulse. Alrighty. Let's talk about stopping then. Airbags are a good example of something reducing the trauma of impact. Trauma being what part of the impact produces trauma. Force. And it does that by changing the time it takes to stop. And which will it be? Do you reduce the force by increasing the time, or you reduce the force by decreasing the time? Good. Increasing the time it takes to stop. All right, we've been looking at things through Newton's laws for this whole unit. Now we got to figure out which one of Newton's laws applies to impulse. I'll give you a hint. That. F equals ma can be rewritten as F equals delta B over delta t. So F equals ma is part of which of Newton's laws? All right, Megan, what do you think? Good. Second. Newton's second law is the basis on which impulse is considered. All right. Force is equal to change in momentum over elapsed time. Change in momentum being the top part, elapsed time being the bottom part. Now let's work through an example. A truck with a mass of 2,000 kilograms, all right, this is mass, and this is mass, right, is moving at 2 meters per second. This is its velocity. Since we don't have a direction, we just say it's positive, even if it doesn't have a plus next to it. So it locks up its brakes, which is always scary because those things don't have those anti-lock brakes. They just lock them up. Smoke comes off their wheels. All right, and it comes to a stop in 5 seconds. 5 seconds is a long time to stop. Most cars will stop in 2 to 2.5 seconds. But if you've got a truck, like one of those big dump trucks full of rocks or asphalt or gravel, it's going to take some time. So it's got all this momentum, and it's stopping in 5 seconds. So let's calculate some things. What's its momentum? P equals mv. M is what? Right. 2,000 kilograms. And we're going to go it times velocity, which is 2 meters per second. This equals what? What's 2,000 times 2? 4,000 kilogram meters per second. I hope you see how that happened. If you don't, back up the video and watch it again. All right, so we need to calculate force now. And force is equal to change in momentum over change in time. So we know what the change in momentum is. If it goes from 2 meters per second to 0 meters per second, the total change is going to be 2 meters per second. All right, so, but it's negative, all right, because it's stopping it. The change of velocity is backwards. So we're going to say delta P is 4,000 kilogram meters per second. I'm going to put it like that. And we're going to divide it, divide it by what? What's the elapsed time? 5 seconds. Good. So what's 4,000 divided by 5? And what are the units? 4,000 divided by 5 is, do it in your heads. All right, Jordan, good. 800 kilogram meters per second squared. We're going to do that correctly. All right, and a kilogram meter per second squared is What? A Newton. Because Newton is a unit of force. All right? And this is called a Newton second because it's a Newton times a second. Kilogram meters per second squared times seconds. Gets rid of one of those seconds. All right, so now we know what's the impulse that it takes to stop if it stops in 3 seconds. I'm sorry, this should actually say no. We're going to do it this way. What is the force that it takes to stop it if it stops in 3 seconds? All right, we're going to do it like the one above it. All right, same thing. Let's do it down here. 4,000 kilogram meters per second divided by, dang it. That's one of the things that's a problem because I still have the touchpad active on my laptop and my hands are big enough I keep brushing it. All right, kilogram meters per second divided by 3 seconds. All right, and that equals, anybody do it in their head? Come on guys, I know somebody can. Summer? Nah, you don't have an answer. Okay, well, let me check with, I've already checked with Xander. How about you? No, don't use your phone. Cool. All right, 1,667. We'll just round up because it's 66666. It just keeps going. And this would be newtons. All right. So, if you have any questions, if you do, you can either email me, call me on Teams, or you can just wait till next week. Hopefully, with any luck, we're going to have an opportunity to sit back in the classroom and do this. So, hope you enjoyed this. This was frustrating to make and remake again, but hope it helped. See you later.